Hi there. Welcome to ArcGIS API for JavaScript, building progressive web apps. My name is Renee Rubalcava, and I'm presenting this presentation with my colleague, Andy Gupp. So let's talk about the agenda for this presentation. Talking about progressive web apps, we're going to talk about what is a progressive web app, what are some of the requirements defined to build progressive web apps, and then how you can use progressive web apps to build efficient applications with the ArcGIS API for JavaScript. And Andy's going to talk about mobile web performance. So first off, what is a PWA? Something maybe you haven't really heard of before, or you have and aren't really too familiar with it. So progressive web apps are defined as web apps that behave like native apps. What that means is that you get prompted for them to get added to the home screen lots of times. And when they're added to the home screen, they actually run inside of a sandbox environment. So when you run them, they actually kind of look like a native application, and they can almost behave like it. The real benefits aren't necessarily in the case that they behave like native apps. The benefits of writing progressive web apps is the side benefit of the performance boost you get by taking even just some of the points of building progressive web apps into consideration when building your apps. So I like to point out the Vitamix website as a good example of a progressive web app because it has smooth transitions from one page to another. It's very, like I said, it's very smooth transitions from one route to another route. It's a responsive application, so when you're looking at it on the desktop, it looks great, and then when you go to a phone device, smaller screen, it's also going to look just like it does on the desktop, but just kind of tweak the size of elements and stuff like that. It's very, very good. It loads very fast, which is key when dealing with progressive web apps because you kind of want to get the page loaded right away and get all of the critical resources loaded into your page as soon as possible. It also kind of has a native look and feel to it, which is really neat, right? If I didn't know any better once I installed this to the home screen, a lot of times I couldn't tell the difference between a web app and a native app on my device. So what are some PWA requirements? There's an acronym used for progressive web apps called PURPLE. P stands for Push Critical Resources. And these are going to be the resources like JavaScript, your CSS, the bare minimum you need for your application to load right away. And you want that because you want to render the initial page or route as soon as possible. You can do this a few different ways. You can go ahead and do something like maybe just show a skeleton of the page, what it would look like without any JavaScript or CSS loaded. That's kind of a good thing. We'll talk about kind of how some techniques and methods you can do with that in a moment. And you also want to pre-cache any remaining assets. So if there are routes in your page which are going to load their own JavaScript and CSS, you can go ahead and pre-cache that JavaScript and CSS to get it ready to get used. That way it's loaded in the browser after the page is loaded. And then when someone goes to that route in their application, those assets are ready for them. This also goes into lazy loading parts of your application. So there might be some larger JavaScript files. For example, things like you have a page that includes or a website that includes an admin page. Not all users are going to go to that admin page. So you would lazy load any JavaScript or CSS for the admin page until they get there. So that wouldn't even be pre-cached assets. They're just going to get loaded as needed, which is critical to get the best performance you want out of your apps, especially with the JavaScript API. Service workers are another part of working with PWAs. Now, these are not web workers. Web workers are different. They're used differently. Service workers have a very unique and defined use case in working with your web applications. It can control and cache your network requests. It's probably the number one thing you're going to do. It's pretty much all I really do with my service workers is I just use it for caching of my assets and any requests that might get used. There's a number of APIs that come with service workers, things like notifications, push for pub/sub capabilities, background sync, and channel messaging. These can get kind of useful if you want to do something like push notifications to the desktop when a feature layer that you might be using in your app has been updated. Maybe there are new features at part of that layer, and you're going to go and do a refresh on it to get those number of features, and then you can let the user know, oh, there are 5 new incidents being reported in your service area. For example, that's just kind of one of the things you can do using service workers. And you push that notification to the desktop, not necessarily just to a browser pop-up or something. So app shell. App shells are kind of cool. I use them for apps that can really benefit from them. I don't think you really need to use them all the time, but they can be useful for certain parts of your application. Places where you would have maybe lots of text and images that would be loaded when the application pulls some data in, but you need to wait for that data to be retrieved, parsed, and then loaded. This way you can allow for the application to look ready while those resources are loaded. So this picture we have on the screen here is kind of a minimal example that you might see in some places where you've kind of defined what you expect the UI to look like, but it's just a dummy UI, right? There's no real data there, but it gives the user a sense of, oh, something is going to happen. I'm just waiting for it to load, right? So you're separating the content from the navigation at this point. The manifest.json. So this is how you kind of define how the PWA is going to behave when it's installed as a home screen app. This means that you can define the icons that will be used in the home screen, what the name of the application is going to be. You can define themes, so you can have a color theme for the background of the app and the browser border, and all these different pieces that you can define for your application when it's installed. You're probably going to want to create multiple sized icons for different devices that are going to have different needs. And there's tools out there that will do this kind of work for you. So some PWA tips. Native image lazy loading. So this is built into modern browsers. It's like you could say it's a somewhat newer feature in the browser. I'd probably say the past few years or so, but basically you can have the option to go ahead and put an attribute on the image as well as iframes called under loading and call it lazy. So loading equals lazy. And what this essentially is going to do is that the image or the iframe won't load until it is in view of the browser, right? So it's going to save loading those assets till you need them. And in the case of iframes, this could be pretty critical if you have an entire website embedded into your application, for example. There's also the picture DOM element, and that picture element can hold a source for where the picture is going to come from, and then you have an image tag under there as well. And the source can have media queries defining that what you want to set the image to when that media query is met. And we'll take a look at how this kind of works in a second here. There's also the IntersectionObserver. So this is how you can use JavaScript to do something like the native image load, lazy image loading, where you can create an observer for the page, and you're going to, well, you can really do it for any element. You're going to observe the element, and when the element changes, it comes into view, you could do something with it. Now, this before the native lazy image loading was available, this is kind of what you would do to load images. I don't really think it's useful so much in that case anymore, unless maybe you want to add a series of images. So you want to add a number of images to the page when you get to a certain section of the page, for example. If not, then just use the lazy image loading and you should be just fine. This could have different use cases of maybe you want to load certain code when someone reaches a part of the page, maybe for ads or who knows what, for example, and you can do all kinds of really cool stuff here. So WebP. WebP is a very efficient image format that now I believe is even available in Safari. So that means it should be available in all modern browsers. So the way you can use WebP if it's supported in a browser is use a picture tag, use the source, and you're going to have a source for the WebP and a source for the JPEG image. And then you have your image tags, whichever one you want to use by default. Now, what's going to happen is that if the browser supports WebP, it'll display that WebP image for you. If it doesn't, it'll go ahead and fall back to the JPEG image. This is a really cool way that you can have fallbacks for images in your applications. The one downside here is that you do have to deploy a WebP and a JPEG image at the same time for your app, or even a PNG image. So you're kind of doubling up on the images, but it's really useful to have efficient pages being loaded for your apps. So all this really cool stuff with progressive web apps and all this efficient loading and techniques that you can use. Well, how do I do that with the JavaScript API? So there are considerations when building mapping apps, right? You want to provide an app shell when possible. So if the map is going to be the focus of the page, and maybe you have some other things going on, maybe display an image that represents where the map will go on the page. If it's going to be a full screen map on the page, then maybe an image of a globe or an image of what you expect the map to be, especially if every time the user loads the page, it's always going to be at the same location. That could be something you could do. And delay loading the map if you can, right? Because the JavaScript API is really powerful, but it has a lot of capabilities. So there is a bit of JavaScript that gets loaded with it. For a built application, you're probably looking at a few hundred K of JavaScript that's going to load to build a map, but it's also going to pull resources to get the map. So it's going to ask for base maps, going to ask for layers, and all of these different things are going to delay the loading of your page when it first starts up. So if you don't need the map right away, don't display the map right away, right? And what the map actually does, if you're using a web map, there are a number of different layers that could be in that web map, just operational layers. We're not even talking about what could be part of the base map. The base maps could have, of course, tile layers, vector tile layers, just about any kind of layer could go in a base map. But there's all these other different kind of operational layers that could get used as well. We check what are the capabilities of the services. So how can your application leverage those capabilities? Is it hosted or is it an enterprise service, right? These are all kind of things that we need to check. Does data need to get reprojected, for example? So we need to pull different parts of the API into your application depending on the needs of your the data that you're using in your app. So this one of the things you just want to make sure that you're going to do is that if you don't need the map right away, then of course don't load the map right away. And there are techniques to that. So you want to determine your app map pattern. And this is something that I found in the runtime documentation. So there's an idea of mapless apps where the map is not the initial focus of your application. For example, you might be displaying a list of locations, and then a user clicks on that location, and then they're taken to a page that's going to display the map, and that's when you need to load the map. You don't need it till they actually select something. You can have spatial tasks running in the background, so maybe you're going to load a page displaying what could be a dummy list of locations, but then in the background, you're doing some sort of geolocation, geocoding search using the API to pull features in, and then you're going to refresh that list when it's ready to go. So this could be like using an app shell to display some where data could go, kind of like a gray text boxes and grayed out images. And then when the data loads, it's going to go and load into the app shell. So this is an opportunity for you to delay map loading, which is pretty critical and something that I've talked about quite a bit. This is also an opportunity to use routing and lazy loading in your applications, right? So if you're using a framework that's going to take advantage of routing, you could use that. And then when you get to that route, that's when you're going to load the JavaScript API. All right, so let's dive into a demo of a very basic application to demonstrate how to build a progressive web app. It's a coffee shop application that's going to use the mapless app pattern that we've discussed. Okay, so let's take a look at how you can build a progressive web app. And I'm only going to show you one way that you can do it. There's actually a handful of ways you could build progressive web apps on your own. What I did is I used Create React App, but Create React App has a template that you can use for progressive web apps. So it's the template CRA template PWA is what you would use. So that's what I used here. And all that really does is create a service worker file for you and has the code already available for you to register that service worker. So that's just one way that you can do it. If you're using Webpack to build your applications, there is a Workbox Webpack plugin that you can also use on your own to do pretty much the same thing. Or you could just write the service worker yourself, which is also completely viable and something that you could use to really customize how you want that service worker to work. The service worker that comes with Create React App uses some Workbox libraries to do things like the pre-caching, does all the basics you expect that a service worker could do, and there's details in here and how it all works. If you wanted to get very specific and lay out certain URL endpoints that you want to cache specifically, you could add them in here. You could add your own regex to maybe cache everything coming from some Google Fonts endpoints or some other maybe CSS libraries that you're using their CDNs. You could do all of that here as well, so they could be cached with the service worker. Like I said, that's entirely up to you. And as I showed you before, in the index file, it has a way that you can register that service worker here, which is really neat and very convenient. So what does this application do? This application is going to use the ArcGIS Geocoder API REST endpoint to find coffee shops near a location. And then I'm going to be able to go ahead and click on one of those coffee shops and display it on a map. So by default, this is what I talked about earlier with the mapless app pattern, where when I first start the application, I don't need a map. I'm basically just going to show a list of locations, click on one of them, and then I'll display a map. And there are some techniques you can use to make this very performant. And I'll actually show you the built app after this. So if I look at the app.js file, you can see it's not too bad. I'm using the material UI for this, but that's not really important. The key here is that there's some state to this application, and the state is going to have things like whether I am going to show the map or not. This is a Boolean, so true or false. If it's true, then I just return empty element, which is where I'm going to display my map. And if not, I'm going to display the list of the coffee shops on the first page. And as I click on each of these, I'm going to dispatch an action to show the map with the payload saying that I want to show the map now. I'm passing the current coffee shop that's been selected, and I'm passing a reference to the container so that my map could be created here. That's really the important part. And I'm using the use reducer hook in a context that is wrapping this application. You could see that in here with the context provider that I created. So the key here is the fact that all of the work has been broken up into these smaller modules here, like this locator one. The locator is what's loaded when the application first starts. And essentially is just going to use the geocode REST endpoint from ArcGIS. I'm going to ask for coffee shops that are nearby this particular location, and I'm only going to want maybe 10 of them. Now, since this is such a simple request to make to the geocoder API, I don't really need the JavaScript API for this part. It's not necessary. If I want to do some more advanced stuff with the location services, then yes, I might bring in the JavaScript API, use the locator tools that are part of the API to do this work, but I don't really need it for here. I can even create the URL myself by using the encode URI component to turn all these values to just a long string that I could pass to a fetch request. Then I'm going to get back the candidates from that request and then display them in the page here. Now, how does all of this kind of tie together and get managed with the state? So I have an app context in here. That app context is going to manage the state of my application. Like I said, I'm using the use reducer hook for this. And when the state has been updated and the show map value is now true, I'm going to call this load map function in here. What that load map function is going to do, it's going to dynamically import a web map module. Right? That's what the await import does, dynamically load it. I'm going to bring a couple functions in, initialize and show location. I'll initialize the map with the element that is part of the page. And then I'm going to want to show the location for the selected shop that I picked here. So what does this data web map module look like? If we come in here, this is where all of the ArcGIS business logic is being done in here. You'll notice I'm even importing the CSS for the API in this module. This way that CSS that I don't need when the application starts isn't loaded. It's just a little bit more of a performance increase I'll get when my application first starts. So I'm going to create my web map. I have some parameters for the map view with the center and the scale. I create my map view in here, and then I'm going to have this exported function initialize that we saw. That's going to tell the map view this is where you should be displayed. I have a show location method that's going to take that shop that I clicked on in here, and it's going to go ahead and create a graphic from that with a default symbol, and then add it to the map view to display it on the map. And that's how I get this graphic show up on here. It even has a pop-up that I can click on that's going to show me the name and the address for the selected shop. And that is pretty much all you need to do. The key here is the fact that I am dynamically loading this module when I need it and not before. So when you build apps with the Webpack, and most build tools, what they'll do is they'll see these dynamic imports in here, and they'll create a chunk or a bundle for this dynamically imported module that'll be an entry point, and then it'll load it at runtime. So what happens if I build this application? Let's check that out. Okay, so here I have my built application running. And one thing I want to show that I didn't show earlier was that my index.html, what I did is I kind of added an app shell here. What I did is I essentially inspected the page after it was built, copied the HTML that it output, and just added it directly to my index.html that gets published to my page. This is going to provide a very quick shell you can see here before everything loads, before it's populated with actual hydrated data. So it's kind of interesting because if I refresh the page here real quick, you'll barely see kind of a flicker of the app shell before it gets hydrated. It's so fast you can hardly tell. So this application works as expected, right? But what's key is that if I look at something like a Lighthouse score, it's going to run that for performance, progressive web app, and best practices. And let's see what that looks like when we run this Lighthouse audit inside Chrome. Awesome. So you can see we got performance of 91. We got 100 for best practices. And our progressive web app scored a 3 out of 3 for fast and reliable, installable, and a 6 out of 8 for PWA optimize, which is really, really good. So you can go down here, if you wanted to, you can go down here and check the Lighthouse notes on how you can improve performance for your application. If you're running this on localhost, a lot of these will be that you don't have redirects to HTTPS. Maybe you're not using WebP at the moment, but you could do that, just like I showed earlier. But if we look at things like the trace here, right, and we look at the state of the application as Lighthouse is doing the audit, never at any point is it blank, which is kind of key. You don't ever really want to have a blank page when your application loads. You want something there, which is kind of what the app shell that I added was for. So let's look at the JavaScript, for example, see what this looks like. So let's go ahead and refresh the page. So my application first loads, I've only got 72K of JavaScript loading in my page. And if I click on one of these and load it, I got a total of 636K, and I add just about a dozen more JavaScript files. And that is for the JavaScript API to be able to do its job of displaying the map, the pop-up, the symbols, and everything else that it needs to do. That's really good, and that's very performant, and that's going to make for an application that loads very fast. And because it's a progressive web app, it's also installable to my device or to my desktop. So at this time, I'm going to go ahead and hand it off to Andy to talk about performance and usability with JavaScript API. Andy.
Thanks, Renee. Now we're going to focus on performance and usability. Our goal is to not just think about applications from a developer perspective. We do that all day long. But to take a little bit of our time, step back, and think about the end user's experience. There are some basic questions that we can ask ourselves. Are the end users productive? Do the end users keep coming back? And are the end users even happy? If the answer to any of these questions is no, or there's simply an interest in improving the application performance, then there's some concrete steps that we can take. For the remainder of this presentation, let's think about applications from a mobile perspective, or even from an older laptop perspective. There's been a saying around for a long time that applications that work well on a desktop machine may not always work so well on a smaller device. And that saying is still true today. Not all of our end users may have a Samsung 21 or even the latest iPhone, for example. Another consideration is that humans have a keen ability to recognize patterns. And when those patterns get interrupted, we notice it. We can become annoyed or even frustrated. And because of this ability, our end users can detect when applications take longer than 16 milliseconds to perform an action. This is a very small slice of time. I often think of it like this. An analogy is if there's a stretch of road that you usually drive where if you go a certain speed, you can make a stoplight. But if the traffic's heavy, you're going a little slower, and you end up at that stoplight, and you think to yourself, oh, it's going to take longer to get to my destination. And that's exactly what the end users go through when they start noticing that actions within the user interface are taking longer than they should. And they pay attention to these things. Why is this something that we need to pay attention to? Performance directly impacts our end users, and they know it. It's real to them. They may not say anything, but they experience it directly when they use our applications. And end users just want to perform their task with minimal hiccups. This is especially true for workflows that users may complete over and over again. If there's a performance problem, a small problem can become a large problem and add up to lost productivity or even frustration over the course of days, weeks, or months. There's two types of performance that we need to pay attention to. How long does it take for the application and its functionality to be ready on the initial load? And how long do certain actions take after the application has been loaded? You may be wondering, well, where do I start? Oftentimes, we as developers have the latest hardware and decent or even fantastic internet connections like gigabit fiber, but not all end users have that. And not all cellular connections are 5G. So I always keep older hardware around to test with. I have an older Android Pixel 2 and even an iPhone 6S. I also have an older desktop machine. In addition to that, Chrome has Devtools, which I'll talk about more in just a second. It lets you throttle internet speeds, and all of these things combined are a good start. And what are some of the things that I should be measuring? Some important examples are the time it takes for the first map tile to display, the time it takes for the user interface to be fully ready so that if, for example, you clicked on a map, you're going to get a pop-up. The time for all the features to completely render within the map view, or even the time for widget actions to complete once the application has loaded. The great news is Chrome Devtools are one of our best friends. All of the developers I work with use these tools almost every day. Getting to know them better helps us figure out many of the performance challenges that we need to address. Here's an example where I'm inspecting an HTTP request header for the map view module, and you can see that here on the left-hand side in the path. And here's some important information on the right that gives a hint into the quality of my internet connection. I can see that the time that it took to receive the first byte when downloading this module, and this is this green rectangle here on the right-hand side, the TTFB, was about 60 milliseconds. Now, I look at a bunch of these requests every day, so I have a general idea how much latency is good. I would know that if this number jumped to 1,000 or 2,000 milliseconds, that this might be an area where there could be a problem. And this is one example of many that could help to narrow down the problem. And it's not just about finding bugs. The Chrome Devtools has an entire tab that's dedicated to application performance. Here's an example where I'm capturing very detailed information on how long the JavaScript engine is taking to actually parse individual JavaScript modules. Now, unfortunately, I don't have time to cover this aspect of Chrome Devtools in this session, but it's well worth getting to know this tool in detail. Let's switch gears into some best practice recommendations. One of our first recommendations is always, when possible, use ArcGIS Online hosted services with the ArcGIS API for JavaScript. These services, when they're hosted in ArcGIS Online, take advantage of a global CDN with highly optimized caching. The cache is optimized for your browser, for the edge servers in the cloud, as well as the backend servers, and it's highly scalable. It's scalable without you needing to configure additional servers. For many on-premise installations, it's expensive to keep hardware idling for that time where you may need additional CPU or memory. Well, it happens automatically with ArcGIS Online. Feature tiling, this is a capability that breaks up server-side spatial queries that would normally return a large number of features. And it splits them into several smaller spatial queries. And it's consistent across applications and across devices. It's this consistency that allows query responses to be efficiently cached in the browser and in the cloud. And this is one of the key reasons why feature layers can scale to millions of users, literally, without having to generate tiles ahead of time. We also use a binary response protocol so that the data that's being transferred to the wire is optimized when it's received by the browser and the API. The processing time and overhead is minimal to absorb that data into the API. Quantization allows for the thinning of vertices. These are thinned based on a given tolerance that is equal to the resolution of the current map scale. And Brotli compression. This is a lossless compression algorithm that can significantly reduce the payload size compared to gzip alone. So take a look at the table on the bottom right of this slide. As a test, we started out with 6.5 megabytes and 10,000 features within the extent of a map. And as you take all of these things that I just talked about as a whole, that's where you really start to see the performance benefits from them. So we started out with 6.5 megabytes. When we applied Brotli compression, we got a 65% reduction in payload. We went from 6.5 megabytes down to 2.3 megabytes. Quantization added on top of that got us another 25% increase in efficiency. Now we're at 1 megabyte. When you add in that we requested only the required fields, PBF, and the feature tile cache, we got a 99.4% reduction in payload. We went from 6.5 megabytes to 40 kilobytes in this particular example. Check out this blog post for more information on how we did that. You can also pay attention to module loading. Not all modules should or need to be declared when the application first loads. If you have a long module list that looks like the one in this screenshot, then we have some solid suggestions for you. Lazy loading. Lazy loading is a fantastic pattern. It lets you reduce the initial size of the app. You defer the loading of individual modules until you actually need them. So if you take a look here, here's a function where you can include the require statement and only load the geometry engine when you need it. This is just one example. So let's take a look at an application. Here I have my sample app, and I've already loaded it. I'm in the network tab, and I'm going to go ahead and use the geometry engine to draw a buffer on my map. The thing I want to point out to you is that this saved 158 kilobytes from being transferred over the wire during the initial load of the app. That is a performance improvement. It also reduced the amount of data that the JavaScript engine needed to parse when that file hit the browser by 656 kilobytes. That didn't have to happen during the initial load because I deferred it, and it increased the loading efficiency of my application. You can also lazy load individual layers. Layers pull down a lot of data, and that process can not only slow down the loading speed of your app, it can also cause bottlenecking for your internet connection. Most of you are probably familiar with this pattern on top, where when you initialize the map, that's where we want to jam as many layers as we possibly can and get them to load on the map. But if they're not needed during the initial map load, we can defer that into a function and use the maps add many method to add our feature layer and graphics layer in this particular example. You should also use as few layers as possible. It reduces the amount of memory, it reduces the amount of CPU and GPU parsing and rendering. So let's take a look at a web map. I'll go ahead and load this up. And this is based on educational attainment in Mexico. And I have many different layers in this map that I can activate. What I don't want to do is load the map with all these individual layers displayed at the same time. What I really want to do is just have this map load with the predominant education attainment levels, and then give the end user the ability to toggle on and toggle off these layers as they see fit. So I'm going to save this web map. I'm going to go back to my slide and load my second demo. And what I've implemented in this custom JavaScript application is a layer list widget. And as you can see, since I saved my web map with just that one predominant educational attainment level layer activated, that is what my application loads with. All the other layers are deactivated until the end user wants to turn them on or turn them off. That is increasing the efficiency of my application. You can also improve performance through visible versus remove versus destroy. Now, visible is just temporary. These features are still in memory, and you can simply just turn them on and off again without re-querying the server. It's very efficient. If you want a longer duration removal, then you use the remove method. The layer is actually removed from the map, but it's still in memory, so you can reuse it if you need it. For permanent removal of a layer from the map, the parent, and memory, you want to go ahead and use the destroy method. Last but not least is simplifying the data. As you've seen throughout my presentation, more features is equal to slower performance. So what can you do? You can set min scale and max scale on layers. You can generalize your data before you publish it and reduce the number of vertices. Quantization will take care of some of that for you, but you can do additional generalization. You can enable web server compression, like gzip, and we talked about Brotli. And you can enable cores and get rid of proxy servers that act as intermediaries between your end users and the servers. So let's take a look at a demo. This is an application that measures the performance in terms of frames per second here in the topmost box, and it's displaying zip code boundaries for the entire United States. And what it's designed to show is as I move this highly dense feature set around, you can see that my application is taking some performance hits. And we're dealing with not only a large number of features, but also a large number of vertices, which is also something that's frequently overlooked. Here I have 12,000 features and 361,000 vertices. So what we can do to improve the efficiency of this app is I can set a scale dependency and vastly reduce the number of features based on the scale that I'm looking at, and we significantly improve what's being rendered and processed by the JavaScript API and the browser and the CPU and GPU on this particular laptop. This is what that looks like under the hood. I divided the zip codes, the counties, and the states into different layers, and I set minimum and maximum scale dependencies. And that's it. We hope that you enjoyed our presentation. Thanks for attending, and if you need to contact us, please feel to reach out to us for any questions that you may have. Thanks, and have a great rest of the conference.
Hi there. Awesome. Thank you for hanging out and watching the Progressive Web App session. So I'm Rene Rukava here with Andy Gupp. We're going to go ahead and cover some of the questions that came up during the session here. We're just going to go from top to bottom and stuff. Note that to help us facilitate going over the questions, we're going to mark them as answered so that they kind of clear up on our queue. But once we do that, the question goes away on your end, so you won't be able to see them anymore. We won't do that for ones that we include links on. So we learned to not do that for things that have replies with links. But if you see a question disappear, don't worry about it. It's just us marking it as answered. So there's a couple of questions here that kind of fall under the same umbrella Are there concepts for offline use cases for PWAs using the ArcGIS API for JavaScript? So not really. The API for JavaScript is not something that you would want to use for disconnected editing, for example. And there's also licensing issues in terms of storing things like basemap tiles and things like that on your devices. And the runtime SDK is really built for that. And that's why runtime is the offline use case you'd want to do to build like an offline app. And it's not very efficient in JavaScript anyway. The benefit, though, is the fact that you could have some sort of a slight, like a almost like a disconnected experience. Say if you have someone go out in the field and you have an app built with PWA and you built them a field app. If they lose connection while they're out in the field, they would still have access to the base maps that they view and that may have been viewed. They're still cached via the service worker, right? So as they move around the map a bit, if they previously were already at that area, it would be available for them to see. The same goes for data and the feature layers and stuff like that. But when it comes to like editing, that's not really something that is, well, I mean, you could do it, but it's not really something that's easy to do or recommended either, right? So that's not really what the point of the PWAs and service workers are for. The point of them is the ability to be able to cache your JavaScript files and your assets and stuff like that. So they load from the service worker cache and thus give you a very fluid and performant application experience. So that's really where the PWA use case comes in. It's not for offline usage in this case. All right, so I'm gonna mark that here. What is the recommended way to do lazy loading of ES modules, right? So you would do it, since you're using ES modules, you could do it with dynamic imports, which is basically an import statement and you wrap the module name. And what's going to happen in that case is that depending on the build wall, most build tools are going to create a chunk file, which basically is just an entry point for that file. And then that's going to have access to other chunk files it's going to create that have all of the dependencies for that file. So that during runtime, if you don't need, like the example that I showed there, you don't need the map right away, it creates an entry file for the whatever files you're going to load and then load them as needed. That's why you can kind of offload loading those files to actually need them. You can also go ahead and do something like add pre-cache tags to that entry point file. And there's some plugins and stuff you can use Webpack to do something like that. Basically meaning that when the application loads, it'll add a pre-cache tag to the script and it'll get loaded during the first application load, but doesn't slow down the performance of your app when it first loads up, right? So that's kind of stuff you can do. So you want to look at dynamic imports for lazy loading ES modules. Possibility of using PWA service worker allowed inspection offline. I think we answered that question with the previous answer. JavaScript 3x had an option to visualize symbolize features on the fly, use dynamic JavaScript functions, whereas 4x doesn't. Is there a workaround? I'm not sure I quite understand this question. Andy, do you understand maybe what they're trying to ask here?
I think that might be, I don't know if it's related to Arcade, but Arcade would be the answer for 4.x.
Yeah, I imagine so.
Either Arcade or Sim. Sim would be. Sorry, go ahead.
Whoever asked this question, if that doesn't cover what you're trying to ask, you might want to go to the Ask the Experts section to give a more detailed question and maybe even a sample of what you're trying to do. And from there, we can help out to kind of cover that a little bit better. I haven't worked with PWAs in a while, so it may have changed, but Apple lacks a lot of benefits of PWAs. For instance, prompting the user to install the PWA, web push notifications, and other features. Is there any suggestions of workarounds to get the most out of PWAs in Apple devices? There's not necessarily workarounds you can do. On the Apple devices, all of the browsers are using Safari under the hood, regardless if you're using Chrome or anything like that. While they're using, what is it, the Apple engine under the hood for everything, right? So there are some limitations there in terms of some things you can do, but there's not really much workarounds you can do. But you still get a lot of the benefits of everything. And I thought service workers work on Apple devices today. but I could be wrong about that. I'd have to double check. I don't work on Apple devices very much. Do you, Andy, do anything much
I
with Apple stuff?
I don't.
No. I mean, you could try asking that and you ask the experts, and might be able to get someone that works Apple devices more that might have a better idea for that, but I don't necessarily know the details of that one, how to do it. Okay, so there's one here. Will combining several layers into one layer improve performance if there's still the same amount of data? You want to cover that one, Andy?
The answer is it depends. It depends on how much data you have. And if you have really dense data sets, we'd recommend that you do some optimization of the data beforehand. I think the general answer is yes. Would you agree, Renee?
Yeah, and there was another question I just pushed into the queue here about does having a lot of layers, maybe 100 plus in your web map that are not set to visible, will that affect loading performance since they are not visible? And the best response to that question is yes, there's still an impact, because if the layer is part of the web map, what we're going to do is we're still going to send a request for information about the map. So there are 100 layers, we have going to send 100 requests because we need to know what the capabilities of the layer are before they can even be initialized into the web map, right? Because we might have some other dependencies we need to bring in to even just load the layer. But in terms of drawing performance, no, since it's not visible, we're not going to request any data. So we're not, as you move the map around and stuff, it's like we're making requests for information, even though it's not visible. We won't do that till you set it to visible. But there are initial requests that are going to be made to pull information about the layer, such as the name, because even though it's not visible, it has to be shown in like the legend or the layer list, right? We need to know if there are sub layers and so on and so forth. So there is network activity for all the layers you do have in your map, just to note of it. So like in the previous question, Andy was asking if you can merge a lot of your layers on your own service on the back end somewhere into a single layer, there is a slight improvement for performance there, especially if it's a hosted layer. We have feature tiles and everything that we can do since it's a single service. And there's a ton of caching opportunities there as well. So I hope that answers that one a bit. So I'll give you mark that answered. Similar to another question above, is Esri looking to have the JS API support layer caching on the client? I think this goes into we talked about with the offline usage and stuff. So no, it's not for offline usage or any disconnected editing. There are performance benefits we get to regular browser caching, service worker caching, and things like that you take advantage of. But definitely not for offline usage. And like I said, there's also some licensing things that pop up with that as well that you need to use the runtime SDK for. So we answered this layers one. There was a question here, but there was a URL when lazy loading was first mentioned with the picture tag. Could you please post here? So I did post a link to the presentation that's on this page for the presentation. Is a PDF, and that has all the information in there. So if there was something during the presentation you think you may have missed, reference the PDF for that. And I believe the generated PDFs should have any links working as well inside of them. In the coffee shop example app, did you put off the potential lag of loading the map when the user selects a coffee shop? If there's still lag there, are you just prioritizing initial load time? Yes, right? So there's always going to be some sort of like maybe a second or so of load time when you display a map, right? Because you think about it, we have to not only hydrate the map area, but we have to make the request for all the base maps, all the layers and everything else, right? So there is a very small bit of load time when that happens. So what we're doing is that we're offloading that until you actually absolutely have to do it. The point of PWAs and in general application performance is to get to the page immediately, because things like Google, and especially if you're concerned about like SEO for your site, they are going, you want that page to load right away so that you get a good Google score and plays well with the search engine and everything like that. So you want a fast loading page. So if you can offload map usage to sometime later during the runtime of the application, then that's the best thing that you can do. So that's exactly what I'm doing. That was the benefit of that. Are function-based React components faster than class-based components by current apps using class-based components? Is it worth rewriting the web? No, I don't. There's no really a performance benefit in terms of class-based components for React hooks. It really has more to do with developer ergonomics in terms of what you're more comfortable writing with. I think class-based React is still incredibly viable. I think hooks can be a little bit they can be tricky at times. I'll say that. This isn't a React session. There's a React session tomorrow, I believe. We cover more of that stuff in detail. But class-based components, they just make sense. Object-oriented programming, there's nothing wrong with it. And they're just as fast as functional React hooks and stuff. All right. Can you lazy load imagery from an external URL to improve performance? Now, assuming you mean like images in your application, yes, you can add that lazy load tag to that. If you mean imagery from like an imagery service, then no, it doesn't. We don't have like lazy loading of imagery from imagery services. And I'm not sure if I'm understanding the question correctly, but I believe that is what you're asking. I hope so. All right, Andy, do you want to get this next one? Do you have example using URL routing with your lazy loading recommendations? As in your coffee shop example, having a deep link to a coffee shop. Do you have something like that for reference for like Angular, how you might do that in an Angular way?
I don't.
No. Yeah, I don't really have an example how to do, or how, I don't have an example showing it, for example, but it would work. Deep linking with apps can be a little tricky sometimes. Not only can it depend on your app, but it can also depend on what services you use to deploy your app, like things like Netlify, Vercel, or things like that, or just your regular app. Server-side rendering could help with something like that. And there's actually I don't have it on me, but you might want to ask in the Ask the Expert section, but there was a blog post on how to use the ES modules build of JavaScript API with server-side rendering with React, right? So there was someone posted up how you can get that all working, and it works pretty good. So those are kind of things that server-side rendering is useful for, because dealing with frameworks, if you never hit the root and you don't launch a bunch of stuff, it gets tricky. So I hope that answers that particular question. There's some more questions in RQ here, so let me go ahead and see if I can cover some more of these. Okay, I'm gonna move over a handful, and if we can answer them, then we will answer them. So give me 1 second here. All right. So in an Angular PWA, Andy, this one's gonna be for you. Andy is our resident Angular expert here. Is it possible to load the map and the layers in the background, so when you load the map into the view, it's almost ready and only need to load the tiles?
I think the answer is no. You have to. There's a couple of different ways to do it, but in general, if you want to lazy load the entire map and its associated layers in a hidden div, you can do that within a component. You can also make requests to feature layers and create a client-side feature collection, but I'd be dubious whether you get any performance benefit out of that by just holding that collection temporarily and then pushing it to the layer.
Like, one thing you could possibly do is, like, if you have a web map, you could do a web map.load. It's going to make all the requests for the data about the web map and the layers. Then you iterate through all the layers that are part of the web map and do layer.load on all of those layers. And then you just let it sit there until you have the view ready. And then at that point, all the view has to do is request the tiles. It doesn't have to load the web map or the layer information or anything like that anymore. It's useful, but again, you're kind of offloading all of the loading of the data before you actually have to draw the data. So it's just kind of a toss-up when you want to do everything. That could eliminate some lag between, like, if you have a certain states in your app where you show a map and you don't show a map. So you can eliminate that lag at that point. It's possible, maybe. I haven't really tried that part, but you could. Okay, so let me mark that answer. Okay, how do I best demonstrate poor performance drawing thousands of points at a high level? The user I'm working with has a very fast internet speed. The general public may not. Andy, I think you covered this kind of in your Chrome DevTools stuff, right? How would you do something like that?
You could certainly use the app that I use to demonstrate those thousands of vertices. I'd say just load that into your app and use that layer, and it's a public layer. I'll see if I can find it in the next 2 minutes. If not, please ask this question back on Ask the Experts web developer forum, and I'll get the link for you.
Yeah, I think even in the DevTools, you can do something like set the network speed, like simulate 3G or something like that, right?
Yep.
So you can throttle the network speed in your developer tools to see what it might look like on someone else's device if you have a very fast machine. A lot of us have very fast machines over here, but when we were thinking about how it might work somewhere else, it might not. So I think we're up on our time of questions. If we didn't answer your question, please go to Ask the Experts, and we'll someone, if not us, will try to take care of it from there. Thank you.